Very similar, but in three-dimensional. Um, what's given is, this is homework number 33. You have a certain function, which is a voltage in this case, v of x, y, z, equal 5x squared minus 3xy plus xyz. Okay, there are three parts. First, we need to find the rate of change of v at the point 3, 4, 5 in the direction of a vector that has this is I plus j minus k. Part B is the question in which direction does V change most rapidly. Again, at this particular point, 3, 4, 5. V is a potential function. It's a function. It's sitting on the surface. It's over a certain region in space. Imagine, in this case, it will be a potential field if you are in physics. This is a problem from physics. So you have a potential field in a certain region of a space, and it's described like that. So for each point x, y, z, you have a certain potential or voltage. All right. And part C is we want to find what is the maximum rate of change. At P. Okay, so the last two are very short solutions, but the first one is where we do most of the work. So the work first, we need to find the gradient vector, okay, at x, y, z. So remember, by definition, it will be del v del x in the I direction, del v del y in the j direction, del v del z in the k direction. So look at this function. In the x direction, we have 10x minus 3y plus yz in the I direction. What do we have in the j direction? We have negative 3x plus xz in the j, and in the z direction there is nothing here, and we have simply xy in the k direction. You all agree with me? All right, so now we need to find the gradient at a particular value at the particular point 3, 4, 5. So when we plug in 3 for x, 4 for y, and 5 for z, then you have the following. You have 38 I plus 6 j plus 12k, like so. Now we need the unit vector. The unit vector okay, it will be v divided by its magnitude. So we have 3, I plus 4j plus 5k. And what is the magnitude? 3 squared, 9 plus 16, 25 plus 25, that's 50, isn't it? Did you get it right? So we have 5 square root of 2. Oh, I'm sorry, that's ijk. That's why. It's I plus j minus k. Thank you. I plus j minus k. I was looking at the point, but the vector is I plus j plus k, and therefore it's square root of 3. So now we do the dot product, and you're going to say that the directional derivative at 3, 4, 5 is del v 3, 4, 5 dot u. In this case, we are looking at 38 I plus 6j plus 12k dot I plus j minus k divided by square root of 3. And the answer will be on the next page. Actually, I'm going to jump to the solution. You can do it at home. The result will be a 32 divided by the square root of 3. Okay. You have 38 plus 6, right? That's 44 minus 12 with 32 divided by square root of 3. So you can do it. You can see it right away. All right, so this is the answer for part A. The part B and C, I don't know if you noticed the comment that I made at the beginning, but where is the maximum rate of change? It's the gradient. Remember, that's the one of the important properties of the gradient. So the maximum rate of change and that will be the result. So it will be 38i plus 6j plus 12k. So what is the value? Well, that will be the magnitude. So maximum ROC equals the magnitude of this particular vector, the gradient vector. So it's equal to the square root of 38 squared plus 6 squared plus 12 squared. And if you calculate it, you end up having 2 square root of 1624 or 2 square root of 4, 6. I don't know if this is a... Yeah. That's it, folks. That's so part B and C are pretty straightforward, and you can see in part B you can see really what the gradient does. It gives you the maximum, the direction in which we obtain the maximum rate of change. All right. There is more on that, and we'll talk about it on. Do we have lab on Friday or regular class on Friday? I'll find out the schedule. All right, guys, I'm done. If you didn't get your test, you came in late, come see me. If you want to talk to me about the test, come to my office in the afternoon.